Good morning, class. Today is another day for another physics lecture. So today we'll be doing connection of potential difference. We're doing connection of potential difference. So we started with current electricity. So you can join us and catch up with us at 2 parts on YouTube. So listen to our tutorials. Go to YouTube and subscribe to the channel 2 parts. So today we'll be doing connection of potential difference. So, like we all know what potential difference is already defined in one of our previous classes. So now we'll be doing today connection of potential difference. Now, for example, if the potential difference of resistors is connected in series, how do I calculate the potential difference of that resistor? Like, I mean, if resistors are connected in series, how do I calculate the potential difference? Now, to calculate the potential difference of resistors connected in series, what do you do? That's to calculate the net or overall potential difference. You add up the individual potential differences in the circuit. Now, for example, I have R1. This is a resistor connected in series to R2, like this. Now, I want to find the net potential difference of these two guys. So what I'll do is I'll calculate the potential difference of R1 across resistor R1, and then the potential difference across resistor R2, and then add it up together. That's going to be my net potential difference of the circuit. So for connection in series of potential difference, we calculate the net potential difference with the formula V, which is my overall potential difference, will be equals to V1 plus V2 plus V3 plus like that. So you get the total number of individual potential differences you have in the cell or in the circuit. So if I have 7 resistors connected in a circuit, I'll add up their individual potential difference to get their net potential difference, which is my capital letter V. So now, for me to get the potential difference of resistors connected in series, I add them up together. Now, what if they are connected in parallel? If resistors are connected in parallel, how do I get their overall or net potential difference? Now, the overall or net potential difference of resistors connected in parallel. Now, it's just a single, the value of one of the potential difference. That's one of the value of the potential difference across the resistor. Now, I have, for example, I have R1 here, and I have R2. That's resistor 1 and resistor 2. This way, they are connected in parallel to themselves. So now, if I want to find the potential difference, the net overall potential difference of these two, it simply means these two must have the same potential difference. So which means I'm just going to pick the value of one. Let me say this one has a potential difference of 2 ohms. And this also has the potential, 2 volts. Sorry. This has a potential difference of 2 volts. And this also has a potential difference of 2 volts. So now the net or overall potential difference of these two resistors is just going to be 2 volts. I'm just going to pick one out of these two, just 2 volts. So now you can say the formula for calculating potential difference of resistors connected in parallel is V is equals to V1 equals to V2 equals to V3, like that, equals to Vn. That's the total number of resistors you have connected in the circuits. Now, don't forget, let's do a little bit throwback. For resistors connected in series, you add them up together. Then for resistors connected in parallel, you just need a single potential difference of the resistors. And that's your net potential difference. Now, example 1, let's move to working examples. Example 1. Now, you can see the diagram on your screen. The diagram on your screen is showing the diagram of a circuit. You can see where we have V. The V where we have the capital letter V equals to 12 volts. We have 12.0 volts. Equals to 12.0 volts. So that is the source of the electric circuit. That's the battery source. And I also have where we have I1 and they put question mark. That's the current passing through resistor 1. And then we also have V1. That's the potential difference across resistor 1. I have the value of my resistor 1 as 1.00 ohms. And I also have resistor 2 as 6.0 ohms. All of that. So that diagram is just the diagram of the circuit. So now, as you can see, I have 3 resistors in that circuit. In that particular circuit in my first this. So now, if you look at the diagram very well, you'll be able to see that my R2 and R3, resistor 2 and resistor 3, they are connected in parallel to each other. How do I know? Because both of their ends are meeting at one point. The two ends of R2 and R3 are both meeting at the point. So which means R2 and R3 are connected in parallel. And then R1 is connected in series to both R2 and R3. Now let's move to the question. The question says the diagram above shows resistors wired in a combination of series and parallel. Now, the first question says find the equivalent resistance of the circuit. That's the first thing I'll do. The first question says find the equivalent resistance of the circuit. Now, how do I find the equivalent resistance of the circuit? Back to the diagram, I can see my R2 and R3 are connected in parallel. So what I'll do is I'll find the equivalent resistance first of R2 and R3, and then the answer I get or the value I get, I'll add it to the value of the resistance of R1. So that's my equivalent resistance. So firstly, I want to find the equivalent resistance of my R2 and R3. So what will I do? I will use, don't forget, in our previous classes, we already did this. So the formula for finding the equivalent resistance of resistors connected in parallel is this: 1 over R2 plus 1 over R3. Don't forget, I'm using R2 and R3 here, not R1. So I'm using R2 and R3. So what's my R2 is 1 over 6, and then my R3 is 13. So this will become 1 over R is equal to, here I can look for LCM. So the LCM of 13 and 6 should be 78. So I can say 6 in 78, 13. And 13 is 6. And 13 in 78 is 6. So this will give me 13 plus 6, which is 19. 19 over 78. Now I'm not done because my equivalent resistance is R, not 1 over R. So for me to get my R, I would say, first of all, let me say 1 over R is equal to 19 over 78. So what I'm going to do here is I'm going to cross multiply. I'm going to multiply this by this and then R times 19. So I'll have 19R is equal to 78 times 1, which is 78. Sorry, 78 times 1 rather. So 78 times 1 will give me 78. So now for me to get my R, I'll simply divide through by 19. Divide this by 19 and divide this by 19. So after doing this, I think, let me use my calculator. 78 divided by 19, okay, that will give me 4.1. 4.1. Now, since I'm calculating resistance, equivalent resistance, my unit is going to be ohms, which means the equivalent resistance of the resistors connected in parallel, in that my example, R2 and R3 is 4.1 ohms. Now I'm not done. The question says find the equivalent resistance of the connections in the circuit. I have 3 resistors in the circuit, so which means it remains R1, and then R1 is connected in series to both R2 and R3. Don't forget, formula for calculating equivalent resistance of resistors connected in series is R is equals to R1 plus R2, like that. So now I'll say my R1 is what? My R1 is 1 ohms plus the equivalent resistance of both R2 and R3, which I just calculated as 4.1. 4.1. So which means the equivalent resistance of the resistors in the circuit is 4.1 plus 1, which should give me 5.1 ohms. Calculated the first question. Answer the first question. Now let's move to the second question in the example. Okay, the next second question says, what is the potential difference V1 across resistor R1? What is the potential difference V1 across resistor R1? So don't forget, I said when resistors are connected in series, their net potential difference will be the value of the sum of the individual potential difference of the resistors. So now I want to find the potential difference V1 across resistor R1. So you can see in the diagram there's a place V1, and there's a question mark in front of it in the diagram. So now first thing is the source of my voltage is 12 volts. That's capital V is equals to 12 volts. So which means there should be a current passing through this. The equivalent resistance of the circuit is 5.1 ohms. And then potential difference of the whole circuit is 12 volts. So now, which means a current has to be passing through the circuit. And don't forget the relationship between current, resistance, and potential difference is V equals to IR. So the first thing I want to find is I want to find the current passing through the circuit. I want to find the current passing through the circuit. Now, how do I find the current passing through the circuit? The voltage or the potential difference of voltage of the circuit or a battery source is 12 volts. So my V is 12 volts. I calculated my R as 5.1 and I'm looking for I, which is electric current, times 5.1. So for me to get the value of my I, let me write this clearly. For me to get the value of my I, I'll have to divide through by 5.1. I divide this by 5.1. I divide this by 5.1. So I'll say 12 divided by 5.1. That should give me 2.4 amperes. Don't forget, electric current is measured in amperes. Okay, so this is the amount of current passing through the circuit. Now, here is something you have to note. Now, when resistors are connected in series, the current passing through the source is the same as the current passing through the resistors connected in series. I'll come again. When resistors are connected in series, the current passing through the source will be the same as the current passing through the resistors. But then when they are connected in parallel, the current passing through the source will be different from the current passing through the individual cells of the resistors connected in parallel. But that for series, it is the same. So which means my IA electric current, which is the amount of current passing through the circuit, is 2.4. So now back to the diagram in my example, I've already calculated this, and then I can see that R1 is connected in series. So which means the current passing through R1 is the same as the current passing through the circuit. So which means the current I1 is the same as 2.4. So I'll say my I1 is equals to 2.4. Now, the second question asks us to find the potential difference V1 across R1. So I can use the formula. Using the same formula, V1 is equals to I1 times R1. I've calculated my V1. Okay, sorry, I'm looking for my V1. My R1 is 1 ohms. And then my I1, which I said is 2.4 amperes, is this. So I'll say V1 is equals to 2.4, which is my electric current, times 1. So my V1 will be equals to 2.4 times 1, 2.4 volts, like this. So now the potential difference across the resistance is 2.4 volts. How do I get this? I said the current passing through the source, the current passing through the source of a circuit will be the same as the current passing through resistors connected in series in that circuit. So that's how I got the value of my I as 2.4. And then my resistance value is 1, which is what I calculated here. And then I said V equals to IR. And then I imputed the formula and then I simplified. So I've calculated for the second question. Now the third question says, find the current I2 passing through the resistor R2. Now here is the tricky part. You know, I said the resistors connected in series, we have the same current as that of the source. But then what of those connected in parallel? How am I going to calculate it? First, I have to calculate the potential difference passing through this parallel connection. I have to calculate the potential difference passing through the parallel connection. Now, if you look at the diagram very well, you can see R2 and R3, they are connected in parallel. R2 and R3, they are connected in parallel. But then R1 is now connected in series to the connection of both R2 and R3. So which means I can say R1 is connected in series to R2, R3. But then the connection between R2 and R3 is parallel connection. So which means R2 and R3, they are going to have same potential difference because they are connected in parallel. R2 and R3 are going to have the same potential difference. But then the sum of the potential difference of R2 and R3 with that of the potential difference of R1 is going to give me that of the potential difference of the source of the circuit, which is 12. Don't forget, I said when resistors are connected in series, their net potential difference will be the sum of the individual potential differences. So now, since R1 is connected in series to both R2 and R3, it means their net resistance will be the sum of the potential difference of R1 and then the potential difference of both R2 and R3. So it means when I had the potential difference of R1, the potential difference of R2, R3, I should get 12 volts. So I'll say my V is equals to potential difference of, I'll call it potential difference of 1 plus potential difference of both R2 and R3. Let me just write it like this. I think this is clear. So I'll say potential difference, which is the net potential difference of the circuit, is equals to the potential difference across resistor 1 plus the potential difference across resistor 2 and resistor 3. Okay, so now the, what I want to find is the potential difference across resistor 2 and resistor 3. So now I say V, my V is 12 volts. The potential difference across resistor 1, I calculated that as 2.4 volts plus the potential difference across resistor 2 and resistor 3. So now I can collect like terms and say the potential difference of resistor 2 and resistor 3 is equal to 12 minus 2.4. So I can say 12 minus 2.4. I think that should give me 9.6 volts. So which means the potential difference across resistor 2 and resistor 3 is 9.6 volts. Now let's come back to the diagram where it's R2 and R3 connected in parallel. Since this R23, which I said potential difference across the two resistors, resistor 2 and resistor 3 is 9.6 volts, then I can say the potential difference across R2 is 9.6 volts, and then the potential difference across R3 is 9.6 volts. Why? Because when resistors are connected in parallel, their net resistance is just one. You can just pick one of the potential difference across the resistor. So which means the two of them is going to have the same as 9.6 volts. So I can just say their potential difference, net potential difference is 9.6 volts. Just one of the individual potential difference of the resistance. So which means I can say my V2 is equals to 9.6 volts. And then V3 is also equals to 9.6 volts. But that's not where we are going. The question says find the current I2 passing across the resistor R2. Now, resistor R2 has a resistance of 6 ohms. Resistor R2 has a resistance of 6 ohms, 6.00 ohms. And then my potential difference 2 is what I calculated as 9.6 ohms. So I'm looking for I2, right? Using the same formula, V equals to IR, I will say V2 equals to I2 times R2. So my V2 is 9.6 is equals to I2 is what I'm looking for. That's the current times 6. So I can divide through by 6 to get my I2. So I'll say I2 is equals to 9.6 divided by 6. And I'll get 1.6 amperes. So which means the current passing through the resistor R2 is 1.6 ampere. As you can see, it is different from the current passing through the circuit. But then that of resistors R1, which is connected in series, is the same with that passing through the circuit. So which means when resistors are connected in series, the current passing through them is not same as that of the current passing through the circuit. So you should have that at the back of your mind. But when they are connected in series, then the current passing through the circuit is the same as the current passing through the resistors. Okay, so let's move to example 2. Okay, example 2 also has a diagram. Okay, the diagram in the diagram we have 4 resistors, and each of them have resistance of 10.0 ohms. Okay. Okay, let me read out the question. 2 resistors connected in series, R1 and R2, are connected to 2 resistors that are connected in parallel, R3 and R4. The series parallel combination is connected to a battery. Okay, they've not given us the potential difference of the battery. Each resistor has a resistance of 10 ohms. Okay, if the wires connecting the resistors and battery have negligible resistance, and the current of 2.0 amperes runs through resistor R1, what is the voltage supplied by the voltage source? Okay, they're asking us to find the voltage supplied by the voltage source, which is capital letter V. The V beside the voltage source, which is the battery, is what they're asking us to find. How do I find that? Firstly, I have to find the net because don't forget V is equals to I R. So the first thing I have to find is I have to find net resistance of the circuit. So how do I find the net resistance of the circuit? Don't forget I have 4 resistors in the cell in this circuit. I have 4 resistors. 2 are connected in parallel, R3 and R4. So I'm going to find the net resistance of those connected in parallel, which is R, 1 over R is equals to 1 over R3 plus 1 over R4. So this will become 1 over R is equal to 1 over my R3 is 10, and then my R4 is also 10. So this will become, the LCM is going to be 10. So 10 in 10, 1 plus 1. That'll give me 1 over R is equal to 2 over 10. And then when I cross multiply, I'll have 2R is equal to 10. So from here, since 2R is equal to 10, I can just divide through by 2 and I'll have my R equals to 5 volts. So which means the net resistance of those 2 resistors connected in parallel, R3 and R4, is 5 volts. So the next thing I have to do is I'll have to add them up. That's with the one connected in series, R1 and R2. So my R1 is 10 volts. R2 is 10 volts. While the equivalent resistance of both R3 and R4 is 5 volts. So the net resistance of the circuit will be 10 plus 10 plus 5. So which will give me 25. So which means the net resistance 25 ohms. Sorry, I'm writing volts. It should be ohms. My bad. It should be ohms. The unit of resistance sorry, is ohms. So which means my net or equivalent resistance is going to be 25 ohms. So now I found the net resistance of the circuit. So what I'm looking for is the voltage across the source. That's the voltage, the potential difference of the battery. Don't forget V equals to IR. And then they told us the current passing through R1 is 2 amperes. The current passing through R1 is 2 amperes. I said earlier that when resistors are connected in series, then the current passing through the resistor is the same as the current passing through the circuit. So which means if resistor 1 has a current of 2 ampere passing through it, then it means the current passing through the source of the electricity will also be 2 amperes. Okay. So now from here I can say V equals to IR. My R is 2 amperes and my R is 25 ohms. So my V will be equals to 2 times 25. So V will be equals to 50 volts. So which means the potential difference across the source is 250 volts. It's 50 volts. So now we have, there should be, okay, you can look through example 3 and then you can solve that. I also prepared some practice questions. For the example 3, you can just check how the example 3, maybe you copy it down, then you can practice it by yourself. The one which says two cells each of EMF 2 volt and internal resistance 0.5 ohms. And there are practice questions. Then that's what is just about so you can just bring your past questions and pick it up, and then you look for questions and then start practicing, and then it's going to stick up. So before our time runs out, I want to play with electric power. So electric power. What is electric power? Some people say power is the rate of doing work. Okay, electric power will be defined as the energy or rate at which electric energy is consumed, or it is the total amount of energy, electrical energy. Okay, you can just add electrical energy because we're talking about electrical power. So you say it is the total amount of electrical energy that passes through an appliance in 1 second. So that's power. Power is the rate at which electrical energy is consumed. That's simply what power is. So the unit of power is watt. Watt is this, and then it is represented by W, and this capital letter count. So this is the unit of what of power. So now power, when we are talking about power, electric power. Now, what is the relationship between electric power, current, voltage, that's potential difference? What's the relationship between power, electric current, potential difference, and then electric current, and then resistance? So the relationship is P equals to IV. That's electric power is equal to electric current times potential difference. So when you have this formula, you should have it at the back of your mind that power is equals to electric current times potential difference. Now, don't forget, we said V equals to IR through Ohm's law. We found out that V equals to IR. So I can substitute IR for V in this my equation here. So instead of writing V, I can just write IR. So I can say P is equals to I times, instead of writing V, I'm writing IR, IR. So this would be I times I will give me I squared. So P is equals to I squared R. Here is another formula for calculating power. So here the first formula for calculating power, P equals to IV. And I substituted IR for V, and I got P equals to IR squared. So now I can also do the same thing and say substitute for I, and then say I is equals to, from this V equals to IR, I can decide to make I the subject of formula, and then I'll say I is equals to V over R. Here I have I is equals to V over R. So I can substitute it back into this formula where it says P equals to IV. So instead of writing I can just write V over R. Okay, so I will say my P is equals to, so instead of I write V over R times V. So V times V is V squared, right? So P is equals to V squared over R. Now here are the three formulas for calculating electric power. P is equals to IV. You use this when you are given the electric current and the potential difference of the appliance or of the circuit. You use this. Now, when you are given the current and the resistance, you use this formula. P is equals to I squared R. And now, when you are given the potential difference and then the resistance, you use this formula. P is equals to V squared over R. Don't forget, the unit of power is watts or joule second, like this. So you use watts or joule second. So this unit of power. So now also there is unit of power. You can say unit of power kilowatt per hour. That's the unit we use in home appliances. So kilowatt per hour is simply the multiplication of 1 kilowatt in 1 hour. That's when 1 kilowatt energy is consumed in a period of 1 hour. So which means 1 kilowatt per hour, like this, is equals to 1 kilowatt times 1 hour. So now when you see this 1 kilowatt per hour, it simply means 1 kilowatt per hour of electrical energy is consumed in 1 hour. So I have 1 kilowatt per hour times 1 hour here. So, and 1 kilo, you know that kilo is 1,000, right? So which means this 1 kilo is equals to 1,000 watts. And then 1 hour is 60 times 60 seconds. So this will give me 3,600 seconds. So if I check this, I calculate this will give me 3,006. Let me just leave it in standard form. I'll just say 3.6 times 10 raised to the power of 6. And I write this in joules. So which means 1 kilowatt hour is equals to 3.6 times 10 raised to the power of 6 joules. Okay, so that will be the end of today's class. Don't forget and subscribe to TPATs on YouTube to follow our lectures for more. And we'll see you in the next class. Have a nice day.